If you walk past a pagoda plant right now, you'd probably stop, admire its massive, vibrant red petals, maybe snap a quick picture and just move on.
Yeah, which is what most of us would do.
Right. But you would be completely wrong because, well, nature is actually pulling this massive visual illusion on you, just hiding right there in plain sight.
It really is. I mean, it's the perfect trap for a casual observer, honestly.
Totally.
You look at a plant and your brain just instantly categorizes it. Like green means leaf, bright red means flower. It's an efficient way to process the world. But that quick categorization makes you completely miss the actual mechanics of what's happening right in front of you.
And today's deep dive is really all about shattering those quick categorizations. We are looking at this brilliant piece of source material published today, actually. March 18th, 2026.
Right, over on qianling.org.
Exactly. The post is titled Notes on Gardening, Part 839, The Fascinating Anatomy of Pagoda Plant. And our mission today isn't just to look at the quirky biology of this one plant. We're really looking at the mechanics of observation itself.
Yeah, we're exploring what happens when an incredibly analytical mind, someone who has spent a lifetime as a self-described software plumber, turns their highly structured gaze away from a computer screen and, well, toward the dirt in their backyard.
So let's just jump right into the deception here. The author of this blog, Ang, he starts off by talking about a pagoda plant he picked up recently during the Lunar New Year.
Mm-hmm.
And he mentions it's putting on, quite a show. You look at the photos he provides, and your eyes immediately lock onto these vibrant, show-stopping red structures at the top of the stem. Literally anyone would look at those and say, wow, what beautiful red petals.
Right, but this is exactly where Ang stops us and says, look closer. Because those bright red structures, they aren't petals at all.
Right.
Botanically speaking, they are the calyx. They're actually made up of sepals.
Wait, hold on. If they aren't the flower, what is a sepal doing, being all bright red and flashy? Because usually, when I think of sepals, I think of those little green leafy cups at the base of a rosebud, the things that just peel back and kind of get out of the way once the real flower blooms.
Yeah, that is the standard operating procedure for most plants, definitely.
Right.
The calyx, which is just the collective term for all the sepals, is typically just protective packaging. It guards the delicate reproductive organs while they grow. But the pagoda plant has completely flipped the script.
Oh, how so?
Well, it uses the sepals as the primary visual attractant. Meanwhile, the true flower, the corolla, is actually just this slender, reddish, tubular structure that just sort of pops out from the center of those massive sepals.
Oh, wow. So it feels like this elaborate theater production where the background scenery is just so loud and so overwhelmingly flashy that it completely steals the show.
Exactly. While the main actors, the actual reproductive corollas, are practically whispering their lines in the dark. That's a really perfect way to visualize it.
But why, though? I mean, I have to push back on this biologically, because that seems like a massive waste of energy.
Oh, how do you mean?
Well, if the plant's ultimate goal is to attract a pollinator, why build this elaborate fake-out with red sepals and hide the real flower? Why not just do what a rose does and make giant red petals?
That is the exact right question to ask, and it really comes down to biological economics. Energy conservation.
Okay.
Petals, the true corolla, are metabolically incredibly expensive for a plant to produce and maintain. They're fragile, they wilt really easily, and they drop off the moment pollination occurs.
Why, they don't last long.
Exactly. Sepals, on the other hand, are essentially just modified leaves.
Oh, interesting. So they're tougher.
Much tougher. They cost way less energy to keep alive, and they last significantly longer. So by turning the protective sepals bright red, the pagoda plant creates this permanent, low-cost billboard that stays vibrant for weeks or even months. Yeah, so the tiny fragile corollas can bloom, get pollinated, fall off, but the giant red billboard just stays up, continuing to attract pollinators to all the other unopened tubes on the plant.
Okay, well, that makes so much sense. It's not just a magic trick, it's an efficiency hack. And Ang actually points out another fungus plant that does this exact same thing, the Bougainvillea.
Oh, yeah, that's a great example.
Yeah, he notes that the relationship between the red sepals and the tubular corolla of the pagoda plant is identical to how a Bougainvillea operates.
Which is such a mind-bending realization if you live in a warm climate.
Yeah.
Like those massive cascading walls of magenta or purple on a Bougainvillea, none of those are petals.
Wait, really? None of them?
None of them. They are modified leaves called bracts. The actual flower is this tiny, almost invisible white tube hidden right in the center.
That is wild.
Yeah. And once Aang points this out, you can never unsee it. You stop passively consuming the aesthetic of a garden and you start actively investigating its architecture. You start asking, like, am I looking at the product or am I looking at the packaging?
Oh, I love that. The product versus the packaging. And what's really fascinating is that Aang's investigation doesn't stop at the physical structure. He moves on to the timeline.
Right, because things change.
Exactly. Because the corolla falls off, the flower transitions into a fruit, and the seeds start to mature.
Yeah.
But this isn't your standard, green turning into a slightly softer green or maybe red situation.
No, the plant has a whole second act.
A dramatic, shifting light show of a second act. Aang actually outlines the visual journey of the fruit developing right there in the center of those red sepals. So stage 1, it starts as a small, green, fleshy berry. Very standard. But then stage 2, it shifts into what Aang describes as a metallic blue.
That descriptor, metallic blue, is just so incredibly evocative, isn't it?
It sounds completely unnatural, like a metallic blue, fleshy berry. That sounds like something straight out of a sci-fi novel. Fleshy fruit shouldn't look like the shiny paint job on a sports car.
Right.
How is a plant in a mundane garden pulling off a metallic sheen?
Well, this is where we have to look at the hower behind the observation. When you see something truly metallic in nature, whether it's the wings of a morpho butterfly, a peacock feather, or in this case, a specific type of berry, you're almost never looking at a pigment. You are looking at structural coloration.
Wait, structural coloration? You mean the berry isn't actually painted blue by some chemical?
Exactly. Pigments absorb certain wavelengths of light and reflect others, but structural coloration relies on microscopic, nanoscale physical structures on the surface of the object itself.
Oh, wow.
Yeah, these structures are shaped in such a way that they literally bounce light waves back onto each other, causing interference. They amplify the blue wavelengths and cancel out the others, which creates that shimmering, iridescent metallic effect.
That is staggering. The plant is basically engineering a microscopic prism on the skin of its fruit.
Pretty much.
But again, I have to ask why. I mean, it already used the red sepals to attract pollinators. The flower is gone. Why go through all the trouble of growing a shiny blue berry just to ultimately ripen into its final stage, which Aang notes is a deep, mature black? Like, why the metallic blue middle phase?
Think about the environment for a second. To a bird flying overhead, a green berry is basically completely invisible against all that foliage.
True.
And a deep black berry might just look like a shadow in the canopy. But a highly reflective, metallic blue berry sitting directly against the backdrop of those bright red, long-lasting sepals.
Oh, I see.
That is a high-contrast beacon. It is a neon diner sign in the middle of a dark highway. The plant specifically wants birds to see that fruit, eat it, and then disperse the mature black seeds inside.
It's a completely orchestrated user journey for the local wildlife. That is brilliant.
It really is.
But, catching a transition from green to structural metallic blue to deep black, it doesn't just happen on a casual Sunday stroll. You can't just glance out your kitchen window once and understand that whole process. You have to be watching obsessively.
Absolutely.
Which begs the question, who is actually taking the time to track a berry's wardrobe changes day by day?
And that brings us to, honestly, the most fascinating part of this source material, the mind of the observer himself.
Yes, because the context of this blog post is just as illuminating as the plant it describes. This specific post is titled, Notes on Gardening, Part 839.
I really want you, the listener, to just let that number sink in, Part 839.
It's staggering. When you dive into the archives of qianmeng.org, you realize this blog has been running continuously since July 2011.
Wow.
Yeah, there are thousands upon thousands of posts, all meticulously categorized by year and by month. Just in the year 2026 alone, by mid-March, he has already published over 230 posts.
That's incredible volume.
And if you look at previous years, like 2024 and 2025, he was hitting over 730 posts a year.
Which means he isn't just posting daily, he's posting multiple times a day. He is documenting microscopic delta changes in his environment.
Right. And in his About section, Aang tells us exactly who he is. He describes his site as the journal of an old software plumber night-long tinkering with free Libra and open source software, which he abbreviates as FLOSS, and occasionally some other stuff he dabbles in.
It is the understatement of the century to say he dabbles.
Totally. Because his projects list is this crazy cross-disciplinary explosion. You have these deeply technical, highly structured programming manuals. He has notes on Elixir and Erlang programming, notes on Python, notes on Haskell, Go, and Rust.
Right, very heavy tech stuff.
He is deeply embedded in the back-end architecture of the digital world. But then, sitting directly next to those programming logs are notes on gardening, Notes on dieting, notes on meditation, notes on photography, and notes on home improvement.
And crucially, the fish.
The fish. Yes, he has notes on fish keeping, up to part 210, by the way, along with incredibly specific betta spawn logs.
I love that.
It feels exactly like a Renaissance-era cabinet of curiosities. You know, those old wooden rooms where a polymath would keep like a weird seashell next to a clockwork mechanism, next to a rare book on philosophy. Except Eng's cabinet of curiosities isn't a dusty room. It's organized with the rigorous, impenetrable logic of a meticulously maintained software code base.
And this is really the crux of the entire deep dive today. Like, why are we talking about his coding background when discussing a pagoda plant?
Exactly.
Because the philosophy of free and open source software flaws and the philosophy of biological taxonomy are fundamentally the exact same thing.
Oh, I'm so glad you brought that up. How do those two connect? Because to most people, writing a Python script and watching a plant grow seem like entirely opposite activities.
Well, think about what a software plumber actually does. When a programmer works on open source software, they don't just look at the shiny user interface, the buttons and the graphics on the screen.
Right, the front end.
Yeah. They pop the hood, they look at the source code, they break the complex system down into its individual modules. They ask, what does this specific line of code do? How does it connect to this other function? Where is the bug?
Okay, I see where you're going with this.
Now, apply that exact same mental framework to a garden. When Eng looks at the pagoda plant, he refuses to just accept the biological user interface, the flashy red sepals.
Ah, right.
He pops the hood, he categorizes the calyx versus the corolla, he tracks the timeline of the metallic blue structural coloration. He is essentially reverse engineering of the plant's source code.
He's debugging the plant. Or, well, more accurately, he's debugging our flawed human perception of the plant.
Precisely. Science, taxonomy, botany, these were the original open source projects of humanity.
Oh, that's a cool way to think about it.
You observe a system, you document it meticulously, and you share those logs with the community so others can build on your knowledge. That's exactly why his support for open knowledge organizations is so deeply consistent with his gardening notes.
That makes total sense.
His blog actively highlights his support for the Electronic Frontier Foundation, the Free Software Foundation, the Tor Project, and Wikipedia. He fundamentally believes that the mechanics of the world, whether they're digital or biological, should be transparent, accessible, and rigorously documented.
It completely reframes the idea of what a tech person really is. Like, we often have this stereotype of the coder locked in a dark room, totally disconnected from nature.
Yeah, the basement hacker trope.
Exactly. But Eng shows us that the analytical engine required to understand a complex server architecture is the exact same engine required to understand a betta fish spawning or a metallic blue berry ripening. It's all just complex systems waiting to be parsed.
And that parsing requires immense patience. When he's writing 730 posts a year, he isn't writing sweeping, dramatic novels. He is acting like a version control system, like Git for the physical world.
Git for the physical world, I love that.
He's logging the tiny incremental commits. Today the berry is green. Tomorrow the berry has a slight blue sheen. The next day it is metallic. He tracks the delta.
Which is such a profound counter-narrative to how most of us live today.
Yeah.
We're constantly swimming in this torrential flood of information. It is so incredibly easy to feel overwhelmed, to just skim the surface of everything, and to accept the easiest, most frictionless categorization.
Which is the red part is the flower categorization.
Right. We just take the shortcut because we're tired. But what Eng is demonstrating is that adopting a tinkerer's mindset, forcing yourself to slow down and meticulously document the mechanics of one specific thing, is actually the ultimate protection against that information overload.
It grounds you. When you focus intensely on the how and the why of a single system, the noise of the world just falls away. You don't need to fly across the globe to find an alien landscape or some sci-fi mystery.
You really don't.
You have structural coloration happening on a microscopic scale on a berry in a pot on your patio. There is immense, unfathomable complexity sitting right there, provided you have the patience to look at it as a process rather than just a static object.
It really all comes down to where you choose to direct your focus. The world is full of these quiet magic tricks, just waiting for an audience willing to notice the sleight of hand. The scenery is always going to try to steal the spotlight from the main actors.
But if you know how to look for the corolla hiding inside the calyx, you'll never be fooled by the scenery again.
Exactly. So as we wrap up today's deep dive, we want to leave you with a lingering thought, something to kind of chew on as you go about your normal routine today. Look around your own environment. What everyday object or system or even a plant on your commute is currently hiding its true form behind a flashy exterior? What is putting on an elaborate show, just waiting for you to apply a little bit of that software plumber logic to see how it really works?
It's time to break out your own mental magnifying glass. Question the user interface of your surroundings.
You might just find your own metallic blueberry hiding in plain sight. Thanks for going deep with us today. Keep asking why, keep looking closer, and we'll see you next time.